In this video, I show you how you solve the friction problem where the task was to calculate the friction of a skier on a slope. On the left, you see which values were given. We have the friction coefficient mu equal 0.082, and the mass of the skier is 62 kilograms. And the slope was given to be 15 degrees. And the goal was to find the friction. Below that, you already see that I calculated the weight of the skier to be 608 Newton. And before we continue on this problem, let's draw a free body diagram into that picture. So we just take the middle of the person and the weight goes straight down. So that is 608 Newton, but we need to find the perpendicular component of the weight. Because the perpendicular component matches the normal force, how the surface pushes back against the skier. The normal force is equal to the perpendicular component of the gravity force. Of course, only the magnitude. And when we see this, we are actually dealing with a triangle, a right triangle, and we can use sine or cosine to find the perpendicular component. And first we identify that this angle is equal to that angle. So this is why the perpendicular component of the gravity force is equal the gravity force times cosine of that angle. And when we plug in the values, so we have 608 Newton times cosine of 15, that is 587 Newton. And this is also the value for the normal force. And now we can calculate the friction. The friction is equal to the friction coefficient times normal force, and we have then 0.082 times 587 Newton, and this comes out to be 48 Newton. This is how you work on problems like this. First, you visualize the problem. You put a free body diagram into the image. This helps you to orient yourself and find relationships. And then usually there's always a right triangle involved where you use cosine and sine when it comes to splitting vectors. And then hopefully you can solve it yourself.